This house wiring is having single phase connection. Okay, so single phase energy meter is connected to it, and MCB is for protection of overload and short circuit or fault, to prevent against this fault or the short circuit. And tube light, ceiling fan, etc. are the loads. So these loads can be connected to the uh, 2-pin switches, 2-pin or 3-pin, their switches and the sockets both, plug arrangement and the socket arrangement. And similarly, the loads can be based on these. So this is the apparatus required, which is shown in your screen. So different switches are there, MCB is there, bulb is required, so bulb holder is also given with the, since these are single phase devices, for tube light, energy meter as well, and these are connected to the 6 ampere switches. So no power switches is mentioned here, but in actuality at our home you may see power switches also, in which 15 ampere or 16 ampere is written. Okay, so now let's come to the theory part. So there are a number of methods of installing a wire system. So there are many types of wiring system. So these are clet wiring, casing wiring, CTS cab type, cab tire sheath, or the PRS wiring, metal sheath wiring, conduit wiring, PVC conduit wiring. So these are different types of wiring. These wirings is nothing but the wire arrangement or the conductor arrangement of wires wrapped by the PVC cables. So in earlier days, the external wiring arrangement used to be there, but nowadays internal wiring system is there. So what are the advantages and disadvantages of these wirings? Let us discuss. So in the internal wiring system, since the wires are hidden in the walls for beautification purpose, first of all, second is the security purpose, so that we are secure, so that if in case we inadvertently or by mistake, if we touch these wiring and say if some part is open or uninsulated, so it will result in short circuit. Okay, that's why these wirings are hidden. And these wirings can be of metal sheets wiring with metal arrangement, PVC is in fact there, or there can be pipe arrangement, or there can be a packing type of system, okay, in the wiring. So in which you can say male and female type of arrangement is there, and the wire is passing through, and these wires are connected to the junction box where these wires meet, and from there it can be distributed to or connected to different loads, and few extra wires for future load arrangements or future connection is also, or extension of the service is also given. Okay, so name of these different wirings is listed here. In this external wiring, the casing used to be either wooden or plastic, but what was the problem which was associated with these? First of all, since it is the external arrangement, so these wirings were prone to air and moisture, and since they were prone to air and moisture, and also mechanical damage could be done by hitting those wirings arrangements. Okay, so by moisture, wood deteriorates. Okay, and wood termites also used to harm these wooden wiring. So earlier days these wooden wirings were there, then it were replaced by the plastic casing. Another problem which was associated with this external wiring was that the safety of the people which are living in the home. So because since these wirings are visible, and it may go for aging as well, so some cracks may develop in this casing of these wiring. So when the cracks are developed, so these wiring, the PVC wiring which is going under this casing will be exposed. Okay, again those PVC wiring, since they are exposed, they are again prone to heat and the moisture available in the houses. Okay, So it will result sooner or later, it will result in the opening of this insulated PVC or these casing. So whenever this conductor become uninsulated and someone if touches these cables or conductors, so he will receive a shock. Next is the gauge number of wires, as this topic is discussed in previous experiment as well, that some numbers are given based on the diameter of the wires, and in Indian system it is known as standard wire gauge, and it is written as SWG. Okay, so for wiring in house, 20 SWG wire is used. This wire is for phase and neutral, and for earthing 14 SWG standard wire gauge is used. Okay, so as I have informed you and explained you in previous experiment as well, that as the number of the wire gauge decreases, its fatness or you can say its diameter increases. And you must have observed that the earth wire and its socket is bigger in diameter in comparison to phase and neutral. Okay, so in general, the house wiring arrangement, there are two wires, phase and neutral, which comes from the distribution pole, and it is inserted in our main switch where energy meter is there, and through that energy meter different, it is connected to different types of loads. Okay, so you can see this diagram. So this is a small diagram of a house wiring arrangement and the load arrangement. So here one phase and one neutral is there, and it is connected to energy meter which is placed in the main switch, or they can be placed separately as well. So in these main switches, earlier days there were fuses present there. So these fuses were HRC fuse, high rupturing capacity fuses. So in which uh, some gum arrangement was there. Okay, so those fuses were calibrated and placed in a particular manner, and some gum arrangement was there, and it was placed there or fused there, you can say. Okay, but if there is a fault, if there is a fault, it means, or you can say if there is overload, then what happens that the large amount of current flows. So when the large amount of current flows, it results in I square RT heating. Okay, so when the heating is more, temperature rises. So earlier those the fused structure, your fused gum arrangement used to uh, melt. So as it melts, so this HRC fuse used to come into the action, and it would disconnect the circuit. Okay, similarly there were rewirable fuses in the MCBs, in the sorry main switches as well, and same rewirable fuses were also present near the switchboard or in the switchboard itself. So the if at all some fault current is there, fuse used to melt, and the appliances and the switchboard switches used to be protected. So you can say that nowadays those fuses in the switchboard as well and also in the main switch are replaced by these MCBs. So these how they are beneficial. First of all, the rewirable fuses which were placed earlier. So in those arrangement, the fuse wire which was thinner in nature. So when it used to melt, we are required to replace that fuse or wire. Okay, which in general we could not do ourselves because some risk was involved. Okay, but in case of the MCBs which are present in the switchboards or near to switchboard, or it is also used as the on-off devices for the power apparatus. You can say AC. You can also use MCB on-off device. Okay, so it is easy to operate. First thing, and second is that mm, it is safe. Secondly, another thing which is particular about the MCBs are that it comes with a particular rating. Okay, so we can connect the particular MCB with a particular load depending upon the current, the load which is drawing. Okay, because we know that the 5 ampere or 6 ampere switches are connected to the loads which draw less current, but the 15 ampere and 16 ampere, okay, whatever it may be, say it is connected to the our microwave, so it draws more current. Okay, so the MCBs which are connected to the wires of the 15 ampere switches or wire arrangement is different from that of the 5 ampere. Okay, so and 3-pin socket arrangement, you know. Okay, the other thing is above and phase and neutral is below. So now in the diagram you can see that this is connected to different loads R1, R2 and Z1, which is further connected to earthing for safety. So these are resistive loads R1 and R2, say lamp loads, and the third is Z1. So this Z1 uh, uh, is our impedance. So it includes all the inductive load, capacitive load, or if the load arrangement is the combination of RL, RC, all are included here. So it is generalized here as a Z1. Okay. So one more thing I remember that another disadvantage with the HRC fuses. Okay. Or you can say those rewirable fuses which were connected to main switches was that, so as their gum arrangement melts, for our security reasons or safety, that if another fault comes, it should be functional, we were required to place that gum arrangement. Generally it used to come with the black color, so it should be replaced. Okay, so again same problem was there, that that replacement of that gum could not be done by the residents of those house. Okay, so we have to call to the electrician for its replacement. But sometimes what we do, we tend to be lazy. Okay, or maybe you can say you have called the electrician and he is not coming today, he is busy, that okay, he will say okay, I will come tomorrow. But in case of electrical appliances and the fusing arrangement, we cannot take risk. Okay, it is two pole MCBs are generally used, and although single pole with neutral, triple pole, four pole are also available depending upon the loads which are connected to it. These are visible in your main switches. Okay, where a cluster of MCBs you can see. So it prevents against overload and the short circuit. I have just mentioned that the loads which are connected, 10% or 15% tolerance is there. That is not a big deal. But if it overshoots, then overload is there, and it may result in the large amount of the current being drawn, which is harmful. And short circuit is the fault. Here, the fault current will, of course, be of large magnitude. So MCB, what it does, it isolates the faulty part of the system with the others. Okay. In earlier days, this problem was also there, that if some fault is there or bigger fault is there in a house, then whole of the circuit used to be, or supply used to be disconnected. But nowadays, this connection can be in a phased manner, or the portion which is affected only that gets disconnected or isolated. Okay, I think we have discussed provide the safety. So this is another circuit diagram of phase wiring. So earlier which I have shown you was of single phase, and this is of three phase. So in this three phase connection, the connection can be connected to all the three phases, or it can be connected to the single phase. Okay, so in the top you must have seen this pole arrangement in which R, Y, B and neutral is there. So wire is taken from here, phase wire and neutral wire, and these are connected to the energy meter as shown in the diagram. So this is the pole and this is the R phase which we are dealing first. So this is connecting to this phase and neutral, and it is going. So this when it is connected to the poles, dotted structure is there. So it is energy meter. So and what we can observe from here, that this is the neutral and this is the phase wire. So neutral is going here and phase wire is going here. So this is the incoming of the phase wire. This is the outgoing of the phase wire. Okay. So these now phase and neutral can be connected to different loads in the parallel arrangement. Okay, it can be the fan, lamp. If it is connected to lamp, then it is also connected to its the regulator. Okay, so now it is connected to say tube light, and when it is connected to tube lights, its associated things, chokes, etc., are also connected. And for safety reason, earthing is also there. So here we have observed that we are using this R phase. Similar connections for other phases, say Y and B, can also be made in a home. Okay. And if some three-phase load is there in the home, then all these three phase will be connected to that three-phase load. Okay. So generally we do not have three-phase loads at home. Okay. But still we do have the three-phase connections at home, especially nowadays in the multi-story buildings. What is happening, say you are living in a 2 bhk house or 3 bhk house, and one mcb is there, and say again ryb and neutral connection is there. So one phase is connected to one room, other is connected to other room, and third phase is connected to say hall if it is a 2 bhk and other flat bath वगैरह. Okay. So uh, why this methodology is adopted? This methodology helps in case of single phasing. So what is this single phasing? Single phasing is the arrangement or system in which one of the phase becomes faulty. Okay. So this arrangement provides the backup. So what is the procedure of performing these arrangement is that first of all we have to draw the circuit diagram and plan the wiring and casing accordingly. Okay, that which type of house wiring which we are going to adopt, how many junction box we are requiring. Okay, two-way switches do we require or not, bed switches are there or not, how many number of loads are of 5 amperes and how many of 15 ampere, etc. And now is the requirement of the wire. So wire is to be purchased according to the length and wire gauges. Okay, so with the help of the pliers and the strippers which we have discussed in the previous class, uh, we can make the connections, and cutting plier was also discussed, so we can cut according to our required length. Okay, so now we have to connect the phase and the neutral wire as shown in the diagram. It means that every load will have phase wire and neutral wire compulsory. So good thing about the phase wire and the neutral wire is that it is interchangeable. Okay, because both the terminals are of same radius. Okay, but earth wire is of different. Okay, so we are required to connect these loads near to the energy meter, so that there can be efficient utilization of wires. So whenever we are doing this wiring, we have to ensure these are the precautions which I am reading out. So what precautions we have to take, that whenever we are requiring to do these connections, we should ensure that the power switch is off and instruments power switch is also off. Okay, next thing is that sometimes what happens, that we are also having the inverter arrangement. So sometimes if we are being safe and we have adopted that, okay, since we are doing this connection of house wiring and connecting different loads to their wiring arrangement, okay, let us switch off the whole main switch. That is good, that is fine. But what happens that if we have not disconnected the inverter system, because if we have disconnected the MCBs or the main switch, so the inverter system will treat this as the disruption of the supply. Okay, so when the inverter is assuming that the supply is disrupted, so it will give the conditioned power or the backup supply from the inverter. And if it is giving the supply from the inverter, it means that you are operating on the live circuit. So that may also, and there should not be any loose connection, there should not be any uninsulated wires, and no joint should be kept open. And MCBs and the load arrangement, MCBs wiring and the loads, all should be of the proper rating. Okay, otherwise it will be a problem. And even when we are disassembling the circuit, we have to first remove the source of the power, unplugging the power cord, pull the plug and not the cable. This is also important. Sometimes what we do, or what children used to do, that they unplug using cable, but cable is not firmly connected. So sometimes it may happen that if you are adopting this practice, the cable will be in your hand and the plug is still in the switchboard. Okay, so that is also a problem.